My name is John Rossi, and I'd like to take you now through a journey and show you and talk to you about what rubber powder can do. What I have in my hand is a 0 to 200 micron, or roughly 250 to 400 mesh. This powder, which was basically impossible to achieve up to 2 or 3 years ago, except from friction, in the sense that it was able to be obtained in very small quantities. This powder here allows us to provide a different use for the mountains of tyres that are at the moment being found all over the world, because it makes what is, or was until recently, an inert, unusable product, except for burning, into a value-added product to the industry. We are now able to utilize these powders in areas which we hadn't thought of. For example, this powder is used as an additive for the manufacturing of glue tiles. Now, it allows the people that use this powder to be able to have a form of insulation which is given to the glue in order to enhance the performance of the glue in relation to the tiles. Another application for the powder is the ability to use the powder, for example, as an additive in paints. And what it does is it allows us to be able to mix the powder with paints to stop humidity from going through, so it can be used as an outdoor paint with a lot of success. Many new applications are being developed which we hadn't thought of, and we're working now with customers to bring these applications to the market. This is EPDM. It's a new product that we have also developed, and we can make into pallets such as the size you see here, and this is useful to the injection molding industry. Its applications are still being discovered at this moment, but this is a new product we're bringing into the market and trying to research with both universities in Germany and some major companies what we can do with it. This product is made out of thermoplastic elastomers and a mixture of rubber. With this product, there's many things we can do, and we're still discovering how far we can take it. This is a product used in the injection molding industry. It's a brand new product because it's a mixture of existing TPEs and rubber, giving us similar properties to the original TPE, but with a substantial cost saving. This is a normal TPE pallet at the moment, which is being used to substitute the wooden pallets. There are many reasons for doing that. One of the reasons is that a wooden pallet which is transported between continents can transfer bacteria and a lot of unwanted bugs from continent to continent with no protection for the environment. With a plastic pallet, one of the advantages of a plastic pallet is that a plastic pallet can be steamed before reuse, and therefore take away any bacteria that's there and make it a very safe method of transporting goods from continent to continent. The disadvantage of a plastic pallet is its cost. It has a large cost in terms of actually acquiring the product, and what we are trying to do is we're trying to use our ComTep as a substitute, and we are doing a first initial trial test to see if we are able to produce a product which is of equal strength and durability but at a substantial cost saving to the marketplace. One of the biggest problems we are facing today as a world is the ability to be able to service the large populations of the world who want to have a living standard which is very similar to Europe or the United States. This requires on our part enormous use of our resources. Recycling is really the only way we're going to solve this problem. If the world cannot learn how to recycle, right, we will lose a lot of opportunities and resources through waste. So we're not about recycling, we're about stopping waste. And what we'd like to do is, in our small little world, which is the rubber world, what we'd like to do is create a closed loop situation. In other words, we want to take a product that's used from its basically lost, put aside, non-usable position, which in this case is a rubber tyre, and transform that product into a usable, value-added product that can be transformed into something that we can use to produce something else. Sometimes even the original tyre. Now, in a small way, we are already going towards that event. If you consider all the retreaded tyres in the world that can now use 11% instead of 3% of rubber that's been recycled, that means we are not wasting 7% to 8% of tyres which before we used to just throw away. Now, these small improvements, which in the context of an industry signifies a 400% growth in the ability to use the powder, make a very big difference long term in what we can salvage. And let me go further. If our technology and what we are putting on the table is able to increase this, let's say to 20% or 25%, that we can use our powder to create new retreads, right? This is contributing to having a powder which comes from rubber tyres, to be able to utilise these to make new product. Now, this is a closed loop. This is our mission. Our mission is to get the tools that are necessary to make our vision occur. In other words, let's provide all the machineries that's required. Let's build proper shredders, proper granulators, machines that can sieve and take out as much powder as possible to be able to reutilize this powder into the marketplace as a value-added product. If we do not recycle, if we do not learn how to recycle, there is a very little chance that we are able to satisfy the growing demands that will be placed on us over the next 30 to 40 years with the emerging and developing countries. So our goal is really to achieve this continuous cycle, a closed loop situation. We take an old tyre and we transform it completely and whole into the use of making a brand new one. So let's divide it. Let's split it, let's cut it, let's shred it, let's separate it, all of its components, and let's reuse those components into the marketplace, whether they be steel or textile or rubber or compounds of rubber, whatever they may be. Let's find a use for these products rather than what we're doing at the moment, which is using them either as burning instruments to produce energy, which is a complete waste of resource, or as fillers for asphalt or cement kilns, which is a really bad way of utilising what is an enormous and grand resource.